All right, this morning we are going to talk about 45, 45, 90 special right triangles. And at the top, these are also called an isosceles right triangle because two of the legs have the same length and two of the angles are the same, both 45 degrees, and then you've got the 90-degree angle, which makes it a right triangle. This formula or picture will be given to you guys on any tests or quizzes, final exams, things like that, so you can use it as a reference to help you solve problems. And so really two things go on in this problem, depending if you know one of the legs or if you know the hypotenuse. So, if you know the leg, then what you do is you multiply that by the square root of 2, and that will give you the hypotenuse. If you know the hypotenuse, what you do is you divide that by the square root of 2, and that will give you the value of the leg. Now, some of these questions are going to use some of the radical information that we simplified and worked with yesterday, so we're going to see that in some of these problems. All right, just in my first example, it says find the value of the variable in each diagram. Write your answer in simplest radical form. This is a 45, 45, 90 triangle. I've got one of the legs, and I know it doesn't ask us for this, but the other leg would also be exactly the same. And the h is actually the hypotenuse here. So the hypotenuse, all that is, it's the leg times the square root of 2. So here, it would just be 9 times the square root of 2. If you want to look at the second diagram, you got to make sure you're identifying what do you have. Here I have one of the legs. The legs form the right angle. So my leg is 2 radical 2. The hypotenuse there is going to be x. So my hypotenuse is going to be, again, my leg times the square root of 2. So x is going to be equal to the leg. We have 2 radical 2 times 2. So we're going to use some of our skills about radicals here. 2 radical 2 multiplied by 2, you are allowed to do that. Forgive me. It's the leg times the square root of 2, not 2. Okay, I can always multiply here. So this 2 is going to stay out in front. Radical 2 times radical 2 is radical 4. And then that actually ends up being a perfect square. So I end up with 2 times 2. And so my x value, or the hypotenuse there, is actually just going to be 4. Now, the third picture here, we actually have the hypotenuse. So 6 right here is the hypotenuse. The hypotenuse, again, is equal to the leg times the square root of 2. So here, this would be 6 equals, x is going to be my leg, times the square root of 2. What I end up doing here is dividing by the square root of 2. And in this case, if you guys remember, we're not allowed to have a radical in the denominator. So I need to get rid of that square root of 2. To cancel that out, I'm going to multiply top and bottom if I'm trying to rationalize the denominator, which is what we're doing here. Get rid of the radical in the bottom, and you just multiply the radical by itself. On the top here, I'm going to have 6 times the square root of 2 over the square root of 4. The whole purpose of doing that is to get a radical in the bottom that's actually a perfect square. And I didn't leave myself a lot of room here. So I have 6 radical 2. The bottom of that, we've tried to cancel out the radical in the denominator. So that perfect square of 4 under the square root simplifies to be 2. Now, don't touch this radical at all, but if you can divide those numbers or reduce that fraction in any way, you are allowed to do that. Don't change the radical. Here, 6 is divisible by 2. So, go ahead and do 6 divided by 2, that's a 3, and then the radical 2 is still there, and the leg there is going to be 3 radical 2. All right, pause this at any time. I went ahead and drew pictures for the 2 examples at the bottom of the page. First example on the left says find the length of a leg of a 45, 45, 90 triangle with a hypotenuse of length 22. So I just drew isosceles right triangle, which is a 45, 45, 90. 2 legs are the same. The hypotenuse is going to be 22 as labeled in the picture. Now, all I have to do here is if I want to find the leg, the hypotenuse is equal to the leg times the square root of 2. So in this case, I know the hypotenuse, the leg is x, and so what I want to do here is I'm going to end up dividing by the square root of 2. Now, this is similar to the last problem where I'm not allowed to have that radical in the denominator, so I'm going to rationalize that. Okay, now across the top I would just have 22 times the square root of 2. The bottom would be the square root of 4. If you're understanding this and you want to skip that step where I'm writing out the square root of 4 and just go ahead and write 2, you could totally do that. I'm just trying to show you where this comes from. This right here is going to simplify to 22 radical 2 divided by 2. Now again, this doesn't always happen. If this is an odd number, this won't be the case, but here, don't touch the radical. If you can actually divide those two numbers, which I can here, you can go ahead and simplify this. So this leg is 11 times the square root of 2. Again, I drew the picture ahead of time. It says find the length of the hypotenuse, so I labeled that with an H of a 45, 45, 90 triangle with legs of length 5 radical 6. So the two legs are the same. This is an isosceles right triangle. And then I haven't written these in the picture, so maybe I should do that. Both of these angles are going to be 45 degrees. As long as you recognize the two legs are the same and the hypotenuse is different, you should be okay. Now, what I want to do here, my hypotenuse is my leg times the square root of 2. So here the hypotenuse is h. This is tricky. The leg is 5 radical 6, and then I'm going to multiply that by the square root of 2. Keep that 5 out in front, and then you can always multiply radicals. Just go ahead and do, they don't have to be the same thing. You just do 6 times 2, this is 12. Now, if you can break this down, that's what you need to do. So in terms of what we were doing, if you want to use a factor tree, you can do that. I'm going to write down the biggest perfect square that divides into 12, and that would be 4. So I would rewrite 12 real quick as 4 times 3. You're trying to get one of those numbers to be a perfect square, because if you have a perfect square, you can go ahead and take the square root and remove that from the radical to simplify it. We already have a 5 out here in front. If you have something in front already, those get multiplied. So this is going to simplify to be 10 radical 3 for our hypotenuse. Alright, on the back it says the distance from one corner to the opposite corner of a square playground is 96 feet. In simplest radical form, what is the perimeter of the playground? Now, if we have a square, technically I could have labeled all these sides with an X because they would all be the same. And what's going to happen here, if I have a square, if you guys remember, if you have a diagonal, square or rhombus, that diagonal is going to take and split those angles it runs into all into equal angles. So these are all going to be 45 degrees. So what we have is two 45, 45, 90s. And if I'm talking about the diagonal would actually be the hypotenuse. So what we have here, my hypotenuse is going to be my leg times the square root of 2. So we know the hypotenuse in this diagram. We're going to divide by the square root of 2. And we're going to end up rationalizing this. Okay, now I'm going to skip that step I'm in right now. This is going to be 96 radical 2 divided by 2. Again, do not touch that radical, but if you can reduce that number, 96 divided by 2, I can do that. This is going to simplify to be 48 times the square root of 2. Okay, now, if you look back, the question asks for the perimeter. So each one of these places where I have an X would be 48 radical 2. So if we're going to work on the perimeter here, I would add up all the sides. So 48 radical 2, 48 radical 2. We would add this all up 4 times, adding this. Or if you want to do 48 radical 2 and multiply that by 4, you can do that as well. So if you add all of these up, you're going to get 192. Now, when you're adding radicals, they have to be like radicals, which they are here. but we don't change what's under the square root. You have 48 radical 2's 4 times, and so that's going to be 192 radical 2 as our perimeter, and we can label this as feet. All right, also going to find perimeter here in example 3. This is an isosceles trapezoid. If you guys remember, isosceles trapezoid mean these two sides are the same, these two angles are equal, and if I didn't have the line written in here, this entire angle and this entire angle would be the same. Not going to be totally necessary for this problem. Now, what I have here, this is going to be 90 degrees here. So this is a 45, 45, 90, so that triangle will add up to 180. Same argument over here. If you look at where the 6 is placed, I could put one here as well. That's actually a leg in that triangle. So these two sides are the same. And so this would be 6, this would be 6. And in this situation, remember the hypotenuse of the 45, 45, 90 is equal to the leg times the square root of 2. Now, the hypotenuse would be, right, this would be the hypotenuse, this would be the hypotenuse. Those two right triangles are exactly the same. So the hypotenuse there is going to be just 6 times the square root of 2, no simplifying to do. So right there, 6 radical 2, 6 radical 2. And if I'm trying to do perimeter here, the only side we don't have labeled is this distance right here, but that's just going to match up with the 8 across the top, because I have a rectangle right there with our right angles. Okay, now to do our perimeter, we're just going to add up all the sides. Just make sure you don't skip anything. So I'm just going to start at the top and go around. I've got 8, and I have a 6 radical 2. I have a 6, I have another 8, I have a 6, and I have another 6 radical 2. Now, we're going to leave this in radical form. So I'm going to go ahead and add the numbers. I've got 8, 6, 8, 6, add those up, that's going to be 28, and then the like radicals we can combine, 6 roots of 2 plus another 6 roots of 2. Remember, just add the numbers in front. That's going to give you 12 times the square root of 2. We can't do anything further here, so there's our perimeter, other than maybe we could label that in centimeters. Really quickly, before I move on from that, if you're thinking like, oh, I missed some of the numbers in the diagram, when you're doing the perimeter of the figure, we are only going around the outside edge. So these two 6's that I had written in the diagram, those are not included in the perimeter. So try not to count those. If you're doing the problem, be mindful of that. Just perimeter, just around the outside of the figure. Okay, this last example has got 2 questions about squares, but approaching from 2 different ways. And they're going to ask you to sketch a picture, so forgive, my squares are kind of rough looking there. But we're going to do the question on the left side first. So this is the perimeter of a square is 44. Find the length of each side. So if you guys think about that, all 4 of the sides will be the same. So if you're given the perimeter, I would do this side, this side, this side, this side added up. They're all the same. I'm going to do 44 divided by 4, which is going to be 11. So each side in my square would be 11. I'll go ahead and add that to the picture. And then the question says find the length of the diagonal. So if I go ahead and just draw one of those in as a reference, what we have here on either side of that diagonal is going to be a 45, 45, 90 triangle. So the diagonal here is actually the hypotenuse. So all we have to do is remember the hypotenuse is equal to the leg times the square root of 2. So my hypotenuse here is the diagonal, actually, and the leg is 11, and then multiplied by the square root of 2, and then there's no simplifying to do in that question. If I slide over to the right side example, this now says the area of a square is 289. Now, I know we're going to draw a picture down in the bottom, but let me just draw a quick reference here really quickly. If you have a square, all the sides are the same, and this always throws people off, but I'm giving you here not the perimeter, but the area. So the area of a square would be the base times the height. In the situation of a square, the base and the height end up being exactly the same number. So I would get 289 equals x times x, or 289 equals x squared. And because I only have the one variable there, that's what allows me to solve that. Now, I'm going to take the square root. Normally, if you're just solving an algebraic equation, you are supposed to put that plus and minus symbol in front of the answer because that equation has two answers. Our question is referring to a shape, so we can't have a negative side length. So when you take the square root of 289, you're going to get 17, and you don't want to put the plus and minus in front. But next year when you get to Algebra 2, you got to use that symbol when you're solving an equation that's not related to a picture. Now, here's my square then. Put the 17s all around. And then it also says find the length of the diagonal. So this is extremely similar to the question we just did. The step is just different to find the length of the side. So my hypotenuse here is my diagonal, and it should be the leg times the square root of 2. So for this question, I'd be looking for 17 radical 2 as my answer.